This little dynamics problem deals with what's called an Atwood machine. It's just simply a couple of masses connected by a cable and either stretched over some sort of frictionless object like this, like let's say that's a bar of glass or something that's very slick with a nylon cord, something like that. Main thing is this is not massive and it doesn't rotate. Most real Atwood machines have a pulley or something, in which case you have to consider the mass in the pulley. But for the purposes of this argument, we're going to assume that this is just perfectly slick glass, and this is just a cord with no friction whatsoever. This mass M1 is greater than mass M2, and we start off suspending it 1 meter above the table here. And the object is to let this thing fall and measure how long it takes to cover 1 meter. And we've already done that experiment. In fact, you can find it online. It's an MIT lab if you want to look it up on YouTube. But it took roughly 4.76 seconds to fall 1 meter. Mass M1 was 560 grams and mass M2 was 550 grams. And what we want to do with this is try to find out what the value of the acceleration due to gravity is by measuring this, the acceleration of this system. And here's the way that works. First of all, let's look at the forces acting on the system of masses. There's the force due to gravity acting on this one, and that one is M1G. And there's the force acting on this one. That one is M2 times G. And if you look at this system like this system of masses like this, you can sort of think of this as like a tug of war, even if it were out on a horizontal plane where this mass is pulling to the right and this one's pulling to the left. It's the same kind of thing. So the net force acting on this system of masses is just this force minus this force, since they're in opposite directions. Or I can write that M1G minus M2G is equal to MA, and M is the sum of these two masses, M1 plus M2 times A. So if I factor out a G, I can say G times M1 minus M2 is equal to M1 plus M2 times A, and divide both sides by M1 minus M2, and that means that G is equal to M1 plus M2 over M1 minus M2 times A. And that's my answer if I know what A is. How do I find out what A is? Well, I know that the height that it falls, H, is equal to 1/2 A T squared. I know what H is, so I can plug that in any time. So I need A. And from this equation, A is equal to 2H over T squared. So G then is equal to M1 plus M2 over M1 minus M2 times A, which is 2H over T squared. So all I have to do is plug in the numbers, and here they are. M1 is 560 grams. That's just 0.560 kilograms. 0.56 kilograms plus 0.55 kilograms divided by 0.56 minus 0.55 kilograms times 2 times H, which is 1 meter, divided by T squared, which is 4.76 squared. And when you put all this in your calculator and calculate it all out, it works out to be 9.798 meters per second squared, or approximately 9.8 meters per second squared. No surprise there. That's what we expect. But that would be a nice laboratory method for calculating the acceleration due to gravity rather accurately.